Okay, we'll move to CFX now, and in particular there are some important updates that occurred at 19.1, so we'll start with those. One of the main ones is the ability to perform cavitation simulations using solely a thermodynamic model. This means that you no longer have recourse to models such as Radial Impellers or the need to tune rate constants, etc., because the occurrence or not of cavitation depends solely on the thermodynamic state, and that means that it automatically takes into account effects arising from local changes in pressure or temperature. So it's ideal for doing hydropumps, diesel fuel injectors, rocket fuel systems, etc. So let's see how it works. The methodology is incorporated in the homogeneous binary mixture, where you must include a real fluid equation of state. So for water, that's very simple because the IAPWS system is actually inbuilt into the code. If it's for another fluid, you set up an RGP table. And then if you perform your CFD calculation and cavitation or flashing should arise due to thermodynamics, that will automatically occur. So this is a good approximation when the timescales for thermodynamic changes are small compared with the flow timescales. If they're not in some sort of extreme flashing events, then this approximation may not be good. You can see here an example where it is good. That's in a diesel fuel injector, where in the very narrow passage you can see the drop in density and the formation of a cavitation region. Obviously with CFX there are always significant changes and improvements to the blade row models. Here the main work has been associated with including solid domains. So this now can happen with harmonic analysis, and so that if you wish to look at temperature effects, you can see in this example simulation there's a hot spot introduced at the inlet passing through the stator and blade. Then this can be solved and analysed. There's been some improvements to the way convergence is achieved, and these are now on by default. Finally, a couple of minor changes. So the first is that there's a new expert parameter called reserve solver licenses that allows you to attempt to book licenses in advance, so that if, for example, you're doing partitioning, when it moves to the solver it will have the necessary licenses. And then secondly, as we mentioned earlier, CFX is now integrated into the new system coupling, so that you can run system coupling outside of Workbench using the new system coupling V2 engine. We've talked in the past about this ability to set an operating map. So here you might have a pump, say, where you want to do the pressure rise versus the flow rate for a number of operating speeds. So how do you do that? Well, you could do it outside of CFX by setting up a Workbench session, but now you can also set that all up within a single setup within CFX, and it uses the multiple solution technology, the MRES files it's had in place for quite a while to do this. So you can now construct a table within CFX, having your data. You can give it indices which describe the order you want these done, the speed you want the device to operate, and the flow rate, and obviously it's going to calculate back for you, say, the total pressure. We're doing a pump, but this could be any system. It doesn't have to be a turbo system. That table can be edited with various tools here, and then you go off and you can run it. So once you've got that table, you can use parameters from it in the setup in just a CEL expression, and CFX is going to loop over this index to be able to do that set of runs for you. and then you can get a set of runs done very efficiently. Second big thing is injection regions. So this is where you've got lots of small inlets. You don't want to represent that as a series of source points. So you can set up virtual boundaries where you read in essentially a table of locations, shape of the boundary, flow rate, etc. It projects those data onto your current grid and runs it. As you refine your mesh, you'll get a better representation of those injections. And whilst that's originally designed for turbine blade cooling, of course it could be any geometry that's got multiple injection sprinklers, any sort of cooling you want, it's out there to do. The harmonic analysis using the Fourier transform method was a beta feature at 19. It's now a fully released feature here, together with many of the tools that support the ease of setup. Going to Blade Editor, one of the key features here is the ability to build radial impellers. So essentially that's an extruded impeller normal to the backplate here, and you can build that. TurboGrid has had a number of enhancements. The main one here that we're showing is the ability to create tip meshes that are non-conform and easy to do. With that brings us to the end of this presentation. So I'd really encourage you to go out there, download 19.2, give it a try. There's plenty more information on other features. We've just highlighted the main ones here. If you download the documentation, you can see all the new features. Any questions, problems, etc., as always, contact us at the support at Leap. Hey, thanks for your attention and really enjoy 19.2. Thanks.